Good evening, and welcome. Whatever brought you here tonight, and wherever you happen to be resting as you listen, I am very glad you decided to come. Perhaps you are already settled under the blankets, with the lamp turned low and the edges of the room gone soft and dim around you. Perhaps you are lying awake at the close of a long and tiring day, or resting somewhere that is not quite your own bed, in those still and quiet hours when almost everyone nearby has already drifted off to sleep. Before we begin, there is one small thing I would love to know. Where in the world are you listening from tonight? If you feel like sharing, leave a quiet word below to say hello and tell me which corner of the world is holding you just now. There is something rather comforting in the thought of so many people scattered right across the globe, all settling down beneath the very same sky at the very same moment. And if these slow, quiet recordings help carry you off to sleep at the end of the day, a gentle like and a soft subscribe do more to keep this little channel going than you might think. Tonight, we are going to think slowly and softly about one of the strangest and most beautiful things that can ever happen in a clear daytime sky. Not a storm, not a comet, not a falling star, but something quieter and rarer than any of those. We are going to talk about what happens when the moon slides exactly in front of the sun, and the daylight drains away in the middle of the afternoon, and for a few short minutes the world falls into a deep and unfamiliar twilight. We are going to talk about a total eclipse of the sun. We will start with what an eclipse really is, and how the smallest, closest world in our sky comes to blot out the largest and brightest. We will look at the lucky accident that makes it possible at all, and at why the sky does not go dark like this every single month. We will stand together in our imagination and feel the light change as the eclipse begins, the strange sharpening of the shadows, the falling chill, the sudden hush that comes over the birds. We will watch the last thread of sunlight break into a string of shining beads and then blaze out as a single diamond. And then we will step into the few still minutes at the heart of it all, when a pearly crown of light appears around a black hole in the sky, and the stars come out at midday. We will ask what that crown of light really is, and why it hides a puzzle that no one has fully solved. We will hear how eclipses once taught us things about the sun we could learn no other way. We will talk, calmly and carefully, about how to watch such a thing without any harm. And near the end, very gently, I will tell you where and when the next one is coming, in case you should ever wish to stand in the shadow yourself. There is nothing here you need to hold on to. There is nothing to study, nothing to memorize, and there will be no questions waiting for you at the end. This is not a lesson so much as a long, slow, wandering visit to something wonderful, and you are welcome to follow along with as much or as little of it as you like. If you drift off somewhere in the middle, long before the shadow passes, please do not feel that you have missed a thing. Drifting off is exactly what all of this is for, and it would be the loveliest possible way to spend the night. So settle in now, as comfortably as you can. Let the pillow take the whole weight of your head. Let your shoulders come down away from your ears and soften, and let your eyes close whenever they would like to. Take one slow breath in, and let it ease all the way out again. And when you are ready, we will begin, very gently, to follow the moon's shadow as it crosses the face of the world. Let us begin with the simplest possible picture of what a total solar eclipse actually is, because the truth of it is easier and gentler than you might expect. You already know the two players. There is the sun, That great fire far out in space, the star we all live beside, pouring out the light that fills our days. And there is the moon, that pale, familiar face that circles the earth, going through its slow round of shapes month after month, now a thin curved sliver, now a full silver disk. A solar eclipse is simply what happens when those two line up, when the moon passes directly between the earth and the sun, and slips into the space between us and the light. Most of the time, when the moon comes around to the same side of the sky as the sun, it does not line up quite perfectly. It passes a little above the sun, or a little below, and nothing at all seems to happen, and we go on with our ordinary day none the wiser. But every so often the line is true. Every so often the moon slides across the sun, so exactly that, from certain places on the earth, it covers the bright face of the sun completely, blotting it out for a little while as though someone had gently pressed a dark coin over a lamp. And when that happens, the daylight does something it almost never does. It begins to fail. Think for a moment about how the moon casts a shadow. Anything solid, held up in the sunlight, throws a shadow behind it, and the moon is no different. As it moves between us and the sun, it trails a long cone of shadow out behind it, a slim, dark spike of shade reaching across space. Usually, that shadow points off into empty space and touches nothing. But now and then the tip of it just reaches the surface of the earth and brushes against the ground. Where that dark tip lands, the sun is hidden, and a small patch of the world falls into shadow in the middle of the day. That patch is not large. The deepest part of the moon's shadow, the part where the sun is fully covered, usually paints a track only 100 miles or so wide across the face of the earth, a narrow ribbon of shade laid down across land and sea. Stand inside that ribbon at the right moment, and you will see the sun go out. Stand a little to either side of it, and you will see only a partial bite taken from the sun, and the day will stay bright. It is worth dwelling for a moment on how sharp that line really is, between standing inside the ribbon of deep shadow and standing just outside it, because it surprises almost everyone. You might think that if you were near the path, seeing the sun almost completely covered, you would get almost the whole experience, a sort of 9/10 eclipse. But it does not work that way at all. Even when all but a thin sliver of the sun is hidden, that last remaining sliver of the true surface is still so fiercely bright that it keeps the sky blue and the corona invisible and the stars hidden away. And you would never guess, from just outside the path, what those inside it were seeing. The difference between almost total and truly total is not a difference of degree. It is the difference between a dimming of the day and an altogether different sight, between watching the sun get bitten and watching it go out completely. That is why people who chase these events care so much about getting inside the true path, even by a few miles, rather than settling for a spot nearby where the sun is almost, but not quite, covered. Almost is another thing entirely, and the shadow does not sit still, because the moon is forever moving along its path, and the earth is forever turning beneath it. That dark tip races across the ground at a tremendous speed, faster than any aircraft, sweeping over the land in a great curving line. So a total eclipse is never something that settles over a place and stays. It arrives, sweeps through, and is gone, hurrying on across the world. For any one spot along that track, the deep part, the true totality, lasts only a few minutes at most before the shadow rushes onward and the sun returns. It is one of the most fleeting sights in all of nature, gone almost as soon as it has come. Now here is the part I most want you to feel, because it is the heart of what makes a total eclipse so unlike anything else. As the moon creeps across the sun, the light does not simply switch off the way a lamp does when you flick a switch. It fades, slowly and strangely, over the better part of an hour, and it does not fade the way an ordinary evening fades. At sunset, the light grows warm and golden and low, and the shadows stretch out long and soft. But during an eclipse, the sun is still high overhead, still shining from the middle of the sky, only shrinking, thinning to a narrowing crescent. So the light that reaches you grows dimmer and dimmer while still falling from straight above, and it takes on a peculiar quality, a cold, silvery, unfamiliar sort of light, sharp and thin, like nothing you have ever seen at any other time. The world grows dim, but it is the wrong kind of dim, a daytime darkness that some deep and ancient part of you knows should not be happening. And then, at the last, the final sliver of the sun disappears behind the moon, and the deep shadow falls. The sky does not go fully black, not the way it does at night. It becomes a strange, rich twilight, a deep, blue-grey dusk in the middle of the day, dark enough that the brighter stars and planets come out overhead, yet ringed all the way around the horizon by a soft glow, as though sunset were happening at once in every direction. In the place where the sun should be, there is now a round hole of darkness, a black disk where the blazing sun used to be, and around that darkness, quiet and pale, a ring of soft light appears. That is totality. That is the few short minutes we are traveling toward tonight. But before we can truly understand how it feels to stand there, we should first understand how it can happen at all, because it rests on one of the most fortunate accidents in the whole of the sky. Here is something that ought to be impossible, and yet is simply quietly true. The moon, which is one of the smaller bodies in our part of space, is able to cover the sun, which is one of the largest things any of us will ever lay eyes on. A little pale rock, no wider than a single country, can hide a ball of fire so huge that 1,000,000 worlds the size of the Earth could fit inside it. How can the small thing possibly cover the enormous thing? The answer is one of the loveliest coincidences in nature, and once you see it, you never quite look at the sun and moon the same way again. It comes down to distance. Hold up a small coin at the end of your outstretched arm, and you can blot out a whole distant mountain behind it, or the face of a friend across the room, or the moon itself in the night sky. The coin is tiny, and the mountain is huge, but the coin is close and the mountain is far, and so, from where your eye sits, they can seem the very same size. What matters for covering something is not how big a thing truly is, but how big it looks from where you stand, and that depends on both its real size and its distance from you. A near thing and a far thing can appear exactly equal if the sizes and the distances happen to balance, and with the sun and the moon, they balance almost perfectly. The sun is a true giant. It is about 400 times wider across than the moon is, a truly immense ball of glowing gas set at the center of everything. But the sun is also very far away, while the moon is close, our nearest neighbor in all of space. And here is the wonderful part. The sun sits about 400 times farther from us than the moon does. So the sun is 400 times larger, and also 400 times more distant, and those two large numbers very nearly cancel each other out. The result is that the sun and the moon, so utterly different in their real sizes, appear in our sky as almost exactly the same size. Each of them covers about the same small patch of sky, a disk about half a degree across, roughly the width of a pea held at arm's length. You could hide either one behind the tip of your smallest finger. Take a moment with that, because it is genuinely strange. There is no law that says a moon must appear the same size as its sun. On other worlds, with other moons, it does not work out this way at all. Some moons are far too small and could never do more than pass across the sun as a little dark speck. Others are large enough or close enough that they would swallow the sun completely and hide everything around it too, blotting out the very glow we most want to see. It is only here, only on our own Earth, only for our own eyes, that the fit is so close to exact. And it is exactly this near-perfect fit that gives us the total eclipse in all its beauty, because the moon just barely covers the bright face of the sun and no more. It hides the blinding disk while leaving the faint outer glow around it on display. Cover the sun with something a little too big, and you would lose that glow. Cover it with something a little too small, and you could never hide the glare. Our moon is the one that fits. I would love to tell you that this perfect fit is a fixed and permanent feature of the sky. But honesty is part of the calm of these nights. So I will tell you the truer and stranger thing instead. The fit is not permanent. It happens to be very close right now, in our own age. But it has not always been so. And it will not always remain so. The reason is that the moon is very slowly drifting away from us. With each passing year, it edges a tiny bit farther out along its path, only about the width of a couple of fingernails, a change far too small to notice in a lifetime, or in 1,000 lifetimes. But over long, long stretches of time, those tiny steps add up, and as the moon drifts outward, it appears, ever so gradually, a little smaller in our sky than it does today. So the leading idea among scientists, and it is a gentle and rather poignant one, is that we are living in a fortunate window. Long ago, the moon was closer and looked larger, easily covering the sun with room to spare. And far in the future, many millions of years from now, the moon will have drifted so far that it will appear a touch too small to hide the sun completely. When that distant time comes, the moon passing in front of the sun will no longer black it out. It will leave a thin, bright ring of sunlight showing all the way around its edge, a circle of fire with a dark center, rather than the soft, pale crown we can see today. There will still be eclipses of a kind, but not this kind. Not the total darkness and the ghostly glow. I do not tell you this to make you sad. That change lies unthinkably far ahead, long past anything that touches you or me or anyone we will ever know. I tell you only because it makes the eclipses of our own age feel like a small and lucky gift, a thing that happens to be possible right now, in the brief span when we happen to be here to look up and see it. If the moon goes around the Earth roughly once a month, and if an eclipse is simply the moon passing in front of the sun, then you might reasonably wonder why we do not have a total eclipse every single month, once in every lap the moon makes around us. It is a very fair question, and the answer reveals something quietly beautiful about the way these things are arranged in space. The short version is that the moon's path is tilted, and because of that gentle tilt, its shadow usually sails past the Earth and misses us entirely, above or below, without ever touching the ground. Let me build the picture slowly. The Earth travels around the sun along a great flat path, like a marble rolling around the rim of a great shallow dish. and the moon travels around the Earth along its own path, going round and round us as we make that yearly journey. Now, if the moon's path lay in exactly the same flat plane as the Earth's path around the sun, then every single month, without fail, the moon would pass precisely between us and the sun, and we would get an eclipse every time it came around to that side. But the moon's path does not lie flat in the same plane. It is tilted at a small angle, leaning by about 5 degrees away from the plane of the Earth's journey. And that small lean makes all the difference in the world. Because of that tilt, as the moon comes around each month to the same side of the sky as the sun, it usually passes a little above the sun or a little below it, rather than straight across its face. Its shadow, that long dark spike trailing behind it, points off a bit too high or a bit too low, and sweeps past the Earth into empty space without ever brushing the ground. So most months, when the moon slides between us and the sun, nothing happens that anyone would notice. The moon is simply a little off to one side of the perfect line, and the daylight carries on unbroken. That gentle miss, month after month, is the reason the sky does not go dark on a regular schedule. The same tilt, by the way, is why we do not have the other kind of eclipse every month either, the kind that happens at the full moon. For just as the new moon usually passes a little above or below the sun, so the full moon, 2 weeks later, usually passes a little above or below the long shadow that the Earth itself casts out into space. Only when the full moon crosses through the plane at just the right moment does it slide into the Earth's shadow and darken, turning a deep and dusky red, which is what we call an eclipse of the moon. So the tilt governs both. It keeps the sun and the shadow and the moon from lining up most of the time, and lets them line up only in those twice-yearly seasons, when the crossing points swing around to face the right way. Solar eclipses at the new moon, lunar eclipses at the full moon, and long quiet stretches in between, when the tilt holds everything gently out of true. But the tilt, though it usually spoils the alignment, cannot spoil it forever. Picture the moon's tilted path crossing through the flat plane of the Earth's journey. A tilted ring and a flat ring, if they share a center, must cross each other at 2 points. On opposite sides, the way 2 slightly leaning hoops laid together would touch in 2 places. Those 2 crossing points are the only spots where the moon is exactly level with the plane of the Earth's path around the sun, neither above it nor below it. And only when the moon happens to be passing through one of those 2 crossing points at the very same time that it slides between us and the sun can everything line up truly straight, and the shadow reach the ground, and an eclipse actually happen. That is why eclipses come in what astronomers call seasons. Twice a year, roughly, the arrangement of the Earth, the moon, and the sun swings around so that one of those crossing points falls near the direction of the sun. During those stretches, for a few weeks, the conditions are right, and if a new moon comes along just then, its shadow can find us and an eclipse can occur. Between those seasons, through the rest of the year, the moon keeps missing, passing above or below, and no eclipse is possible no matter how the moon may line up. So eclipses are not scattered evenly through the calendar. They cluster, arriving in these twice-yearly windows, when the tilted path and the flat path and the sun all agree. And even when an eclipse does happen, it is very often not a total one, and not visible where you happen to live. Sometimes the moon is a little too far out along its own path, so that it looks slightly too small to cover the sun fully, and you get that bright ring of sunlight around it instead of true darkness. Sometimes the alignment is only rough, and the moon merely clips the edge of the sun, giving a partial eclipse that dims the day only slightly. And even a full total eclipse, when it does come, lays down its narrow ribbon of deep shadow across only a thin strip of the whole planet, often falling across empty ocean or frozen wilderness or lands where few people live. So for any one particular place on the Earth, a total eclipse of the sun is a genuinely rare visitor. If you simply stayed in one town and waited, you might wait a few hundred years, on average, between one total eclipse passing overhead and the next. That is a large part of why these events feel so special, and why people will travel halfway around the world to stand for a few minutes in that racing band of shadow. It is not that eclipses are so terribly rare across the Earth as a whole. It is that they so seldom come to you. Let us stop talking about eclipses in general now, and go and stand in one. Imagine that you have traveled to a place where the shadow is going to fall, and that you are standing outside on what has begun as a perfectly ordinary day. The sun is up, the sky is clear, the air is warm on your skin. Around you, if you have come to a good spot, there are perhaps other people, quiet and waiting, and beyond them the wider world goes about its business. The birds calling, a breeze moving through the grass, everything exactly as it always is. Nothing feels unusual yet. But high above, the moon has already begun its slow approach across the sky, creeping invisibly toward the sun, and in a moment the first sign will come. That first sign is called first contact, and it is a small and almost shy thing. If you were watching the sun safely through a proper dark filter, you would see the smooth, round edge of it suddenly show a tiny flattening on one side, a small dark notch, as though something had taken the gentlest possible bite from the rim. That notch is the edge of the moon, sliding at last across the face of the sun. For the first while after that, honestly, very little seems to change. The bite grows slowly, minute by minute, the dark curve of the moon eating steadily further into the bright disk. But the sun is so fiercely bright that even when a good part of it is covered, the day around you stays warm and bright and ordinary. And if you did not already know what was happening overhead, you might not notice anything at all. The sun does not need much of itself uncovered to keep the world looking like day. There is a reason for that stubborn brightness, and part of it lies in your own eyes. The eye is a marvelous thing, and it quietly adjusts itself to whatever light it is given, widening and narrowing to keep the world looking much the same across a great range of brightness. So as the sun slowly dims through the partial phases, your eyes keep pace, opening a little to gather more of the fading light, smoothing the change so gently that you scarcely feel it happening. Only when a very great deal of the sun is gone, far more than half of it, more even than 9 parts in 10, does the failing light finally outrun the eye's patient adjusting, and the strangeness break through at last. That is why so little seems to happen for so long, and why the final change, when it comes so quickly. The dimming was there the whole time. Your own eyes were simply hiding it from you until they could hide it no longer. But if you are patient, and you keep watching the light around you rather than the sun itself, you will begin to notice the strangeness creeping in. As more and more of the sun is hidden, and only a shrinking crescent of it is left to light the world, the daylight starts to change its character in ways that are hard to name but easy to feel. The light grows weaker, of course, but more than that, it grows odd. It takes on a thin, cold, silvery quality, sharp and clear and a little metallic, quite unlike the warm gold of a normal afternoon. Colors look faded and strange. Shadows grow strangely crisp and hard-edged, because the light is now coming from only a thin sliver of sun, rather than a broad round disk, and a narrow source casts sharper shadows than a wide one. Look at the shadow of a leafy tree on the ground, and you may see something lovely. Every little gap between the leaves acts like a tiny pinhole, and casts its own small image of the shrinking sun, so that the ground beneath the tree becomes covered in hundreds of little crescents of light, a scattering of glowing curved slivers where there used to be ordinary dappled spots. The whole world beneath the trees turns to crescents, and you begin to feel it on your skin too. As the sun narrows, its warmth fades and the air grows cooler, sometimes noticeably so, a chill settling over a day that ought to be warm. It is the temperature dropping in the middle of the afternoon, as though evening had come far too early. A breeze may spring up, a cool eclipse wind, as the changing warmth stirs the air, and around you, the living world begins to sense that something is wrong. The birds, who a little while ago were singing in the ordinary way, grow uncertain and then quiet, some of them falling silent, some beginning the songs they usually sing at dusk, fooled into thinking that night is falling. Cows and horses in a field may begin to drift toward the gate, as they do in the evening. Flowers that close at night may begin to fold. The whole of nature, reading the fading light, starts to prepare for a nightfall that has come at the wrong hour. Then, in the last minutes before totality, everything quickens, and the changes come fast one upon another. The light drops away more and more steeply now, for the last thin crescent of sun is vanishing, and each moment carries away a larger share of what remains. The sky overhead begins to deepen toward a strange dark blue. If you look to the horizon in the direction from which the shadow is coming, you may see it approaching, an actual wall of darkness, a great dusky shadow racing toward you, across the land or the sea faster than you can easily believe. The leading edge of the moon's shadow sweeping over the world. And just before the sun disappears entirely, if the ground beneath you is pale and plain, you may catch one of the rarest and most delicate sights of all. Faint ripples of light and shadow, thin wavering bands, may come stealing across the ground, shimmering and shifting like the patterns of light on the bottom of a swimming pool. They are called shadow bands, and they are a subtle, flickering thing, caused by the last narrow beam of sunlight trembling as it passes through our restless air, and they drift across the pale ground in the final moments, like something half dreamed. And then, with the shadow nearly upon you, and the last thin edge of the sun about to vanish, the light does something unforgettable, and it is worth its own quiet chapter to tell. In the very last seconds before the sun is fully hidden, when only the thinnest possible sliver of it remains, the eclipse gives you one of its most exquisite gifts, and it happens because the edge of the moon is not smooth. We tend to imagine the moon as a perfect round ball with a clean, even rim, but it is nothing of the sort. Its edge is rugged and broken, lined with mountains and crater walls and deep valleys, a jagged silhouette of high peaks and low gaps. And in these final moments, as the moon covers all but the very last edge of the sun, that ragged rim comes into play in the loveliest way. The last sliver of sunlight does not simply narrow to a line and wink out all at once. Instead, the mountains along the moon's edge begin to block the light in some places, while the valleys still let it stream through in others. So the thin remaining thread of sun breaks apart into a row of separate glowing points, a little string of brilliant beads strung along the dark edge of the moon, each one a shaft of sunlight pouring through a gap between two lunar mountains. They shine there for a second or two, a curved line of bright drops against the darkening sky, like a broken necklace of light, or like the last few embers of the day glowing along the rim of the moon. These are called the beads of light, named long ago for the astronomer who first explained them, and they are one of the most delicate sights the whole event has to offer, there and gone in a breath. One by one, as the moon slides further across, those beads wink out, each valley closing off as the dark edge advances, until at last only a single bead remains, one final point of sunlight blazing at one edge of the moon, while the rest of the sun has already vanished behind it. And now comes the sight that gives this moment its name. That single brilliant point of sunlight, burning at the edge of the dark disk, together with the first faint ring of pale light, just beginning to appear all the way around the moon, forms a shape exactly like a ring, with a single glittering jewel set upon it. It is called the diamond ring, and it is one of the most beloved sights in all the sky, a band of soft light encircling the black moon, with one dazzling diamond blazing at its edge. For a heartbeat or two, it hangs there, that ring and its diamond, almost too bright and too perfect to seem real. And then the last diamond fades. The final point of direct sunlight slips behind the moon. The bright bead shrinks and vanishes, and with it goes the last of the ordinary daylight. In that instant, the whole character of the sky changes. The glare is gone. The blinding disk of the sun is completely covered at last, hidden entirely behind the dark body of the moon. And in the sudden absence of that glare, the thing we have been traveling toward all this time finally reveals itself, quiet and pale and waiting, a soft crown of light spread out around a circle of darkness, where the sun used to be. Totality has begun. The diamond has closed into a ring, and the ring has opened into something stranger and more beautiful still. Hold on to this moment, because we are about to step into it, into the few short minutes that people cross oceans to witness, and that no one who has ever seen them seems able quite to forget. And now the day is gone, and you are standing in the shadow of the moon. Let us slow down here, and let this part unfold at its own gentle pace, because everything else has been leading to it, and because it lasts such a little while that it deserves to be dwelt on softly for as long as we can. Look up first at the place where the sun used to be. There is a round disk of pure black hanging in the sky, darker than the twilight around it, a clean dark circle where the blazing sun ought to be. That black circle is the moon, of course, its unlit side turned towards you, though in that moment it does not feel like the familiar moon at all. It feels like a hole cut in the middle of the sky, an opening onto something behind the day. And around that dark circle, reaching out on every side, there is a soft, pale, pearly light, faint and silvery, streaming outward in delicate rays and feathery streamers. It is not a hard, bright ring. It is a gentle glow, uneven and soft-edged, with long pale plumes reaching out from the top and bottom and sides like the petals of some ghostly flower, or like long strands of pale silk drawn out around the darkness. That soft crown of light is the outer atmosphere of the sun itself, and we will come to what it truly is very soon. For now, simply look at it. It is one of the few sights in all of nature that people describe again and again in the same words, as something they were not prepared for, something no picture had readied them to feel. Look closely too, at the very edge of the black disk of the moon, right where it meets the pale crown, and you may catch something else, small and startling, and a deep rose pink. Here and there around the rim, tiny tongues and arcs of pink-red light may stand out against the dark, like little flames licking up from behind the moon. These are called prominences, great arcs and fountains of glowing gas rising from the surface of the sun itself, held up and shaped by its magnetism, looping out above the edge. Each one is far larger than the whole of the earth, though from here they show only as small pink flickers at the rim of the dark. They glow that particular rose color because of the kind of gas they are made of, the most common gas in the sun, lit up and shining. On some eclipses there are many of them, ringing the dark moon with little pink flames. On others only one or two, or none at all, depending on the mood of the sun that year. If you do see them, they are a small gift, one more delicate detail in a sight already full of them, and they vanish the moment the sun returns. Now bring your eyes down from that crown and look at the rest of the sky, because it has changed completely. It has gone a deep, dusky blue, dark as a rich twilight, dark enough that the brighter stars have come out overhead, shining quietly in the middle of what was, a few minutes ago, a bright afternoon. Near the darkened sun, you may see one or two of the planets, points of steady light that have appeared as the glare died away, keeping watch over the covered sun. To see the stars come out at midday is one of the strangest gifts of an eclipse, a small overturning of the natural order, night's own lamps lit while the day still stands around you. And then look lower still, all the way around to the horizon in every direction, and you will see one of the most beautiful and least expected parts of the whole thing. All the way around the edge of the world, in a great unbroken circle, there is a warm glow, soft bands of yellow and orange and rose, the colors of sunset laid down along the whole rim of the sky at once. It looks as though the sun was setting everywhere around you at the same moment, in the north and the south and the east and the west together. And that is very nearly what it is. For out beyond the narrow band of deep shadow you are standing in, out past the edge of the moon's dark footprint, the day is still bright, and it is that distant sunlit sky, ringing you round on every side, that glows so softly along your horizon. You are standing in a small pool of night, no more than 100 miles or so across, with the sunlit world glowing gently all around its edge. Few sights give you so strong a feeling of standing inside a shadow, of being able to see the very shape and the edge of the darkness you are in. There is a hush that comes with all of this, and it is one of the things people speak of most. Some of it is the natural world falling quiet, the birds gone silent, the insects of the evening beginning their songs by mistake, the ordinary daytime sounds all suddenly stilled. But some of the hush is human. People who have stood in totality often say that a great quiet comes over the watching crowd, a hell breath, and then sometimes a rising sound of gasps and soft cries, and even weeping, an outpouring that seems to come loose in people all at once. It is a curious thing to say about a piece of astronomy, but the accounts are remarkably alike across all sorts of people, from every kind of background, across the whole span of history. There is something about standing in that sudden cool darkness, under that pale crown, with the sunset glowing all around and the stars come out at noon, that reaches past all our knowing and touches something older and wordless in us. Even people who understand exactly what is happening, who could explain every part of it, describe being caught off guard by the sheer feeling of it, by a wave of wonder that no amount of understanding seems to soften. Feel, too, how the air has changed. It is cooler now, sometimes markedly so, the warmth of the day drawn off in these few dim minutes. There is a stillness to it, often, the eclipse wind having dropped away into calm. The light on the faces and the landscape around you is like no other light, a soft, shadowless, silver-grey glow, faint and even and strange, coming from that pale crown and from the ringed horizon rather than from any sun. Everything looks a little unfamiliar in it, a little dreamlike, the ordinary world lit by an extraordinary lamp. And all the while, some quiet part of your mind is aware that this cannot last, that the shadow is racing on even now, that the few minutes you have been given are pouring away, and they are only a few minutes. That is the thing to hold gently in mind as you stand there. Totality is brief, always. For most eclipses, at most places along the track, it lasts only 2 or 3 minutes, sometimes less, a short and precious window before the light returns. On rare and especially favorable occasions, when the moon is riding close to us and the alignment is at its very best, totality can stretch out as long as about 7 minutes, which is close to the longest that is ever possible on the earth. But such long ones are uncommon, and even 7 minutes is a small handful of moments to hold something so rare. Most who witness totality find that it seems to pass in a breath, that it is over almost before they have understood that it began, and that they are left staring at the sky with the feeling that they must have missed half of it, though they never took their eyes away. There is a lesson somewhere in that, about how the most precious things are so often the briefest, but I will not press it on you tonight. I will only say that if you ever do stand in that shadow, you might try, in the middle of all the wonder, to simply be there and let it happen, and not spend the whole of it wishing it would last. It will not last. That is part of what it is. Let us go back now to that soft, pale crown of light that appeared around the dark moon, because it is the true prize of a total eclipse, the one part of the whole event that you can see with your own unaided eye at no other time, and because hidden inside it is one of the honest unsolved puzzles of all of science. This crown of light has a name that simply means, in an old language, a crown. Astronomers call it the corona, and it is nothing less than the outermost atmosphere of the sun. We usually think of the sun as having a clear, sharp surface, the bright round disk we see in the sky, and in a way it does. But that bright disk, that visible face, is not really a solid edge. It is simply the layer of the sun from which the light we see comes streaming out, the glowing surface of the great ball of gas. And above that visible surface, the sun does not simply stop. It has an atmosphere, layers of thinner and thinner gas, reaching out far beyond the bright disk, growing fainter and fainter as they go. The corona is the outermost of these, a halo of exceedingly thin, hot gas streaming out from the sun in every direction, reaching out for millions of miles into space, far wider than the sun itself. It is always there, always streaming out around the sun, but we cannot normally see it because it is so faint, and the bright disk of the sun beside it is so overwhelmingly, blindingly brighter that its glare drowns the delicate corona out completely, the way the flame of a candle would be lost beside a searchlight. Only when the moon slides across and covers that blinding disk exactly, hiding the glare while leaving the fainter halo showing, does the corona finally step out of hiding and become visible to us. That is the deep reason a total eclipse is so treasured. It is our one chance standing here on the ground to see the outer atmosphere of our own star with our own eyes. The shape of the corona is not a plain, even ring. It has structure, delicate streamers and plumes and loops, reaching out in graceful curves and long, feathery rays. Those shapes are drawn by the sun's magnetism, by invisible magnetic forces threading through the thin gas and pulling it into arcs and streamers, the way iron filings arrange themselves into curves around a magnet. The corona even changes its overall look, depending on how active the sun is feeling at the time. When the sun is calm, the corona tends to stretch out into long streamers along its middle, flattened and elegant. When the sun is stormy and active, the corona grows fuller and more even, bristling out on every side. So no two eclipses ever show quite the same crown. Each one is its own arrangement of light, drawn fresh by the state of the sun in that particular year. And that crown does not simply hang there quietly around the sun. It is always streaming, always flowing outward, so thin and so hot that the sun cannot hold it down, and it pours away in every direction, out across space, on and on. That endless outward flow of thin gas from the corona has a name of its own. It is called the solar wind, a constant faint breath of tiny particles streaming off the sun and filling the whole of the space between the worlds. It blows past the earth day and night, though we are wrapped in defenses that turn it aside, so that we never feel it. And when it grows gusty and stirred up, and reaches the top of our air near the poles, it lights the sky there with the soft shifting curtains of the northern and southern lights. So the pale crown you see for those few minutes during an eclipse is not a still and separate thing, sitting only around the sun. It is the near end of a wind that reaches all the way out past every planet, the very beginning of a breath from the sun that we live inside our whole lives without ever knowing it is there. Now here is the puzzle, and it is a real one that scientists will tell you plainly they have not fully solved. You would naturally expect that the further you get from a fire, the cooler it becomes. Stand close to a bonfire, and you feel its heat. Step back, and the warmth fades. So you would expect the sun to be hottest at its visible surface, and to grow cooler as you move outward into its thin atmosphere, further from the source of all that heat. And for a little way, that is true. But then something happens that ought not to happen. As you go outward into the corona, the temperature does not keep falling. It leaps upward steeply. The visible surface of the sun, the bright face we see, is hot, of course, at something like 5,500 degrees. But the corona above it, that faint, thin crown, is far hotter still, reaching a temperature of between 1 and 2 million degrees. The thin outer atmosphere of the sun is hundreds of times hotter than the surface beneath it. It is as though you stepped back from the bonfire and found the air growing hotter the further away you moved, which makes no ordinary sense at all. This is called the coronal heating problem, and I want to be honest with you about where it stands, because that honesty is part of what makes it interesting. Scientists do not fully know why the corona is so much hotter than the surface below it. It is a genuine open question, one of the real unsolved puzzles about the star we live beside. There are good ideas, and they are being tested with care. Some think the answer lies in the sun's restless magnetism, in countless small explosions and snapping magnetic threads high in the atmosphere, each one giving up a little heat into the thin gas, and all of them together keeping it fiercely hot. Others think the heat is carried up by a kind of wave rippling along the magnetic threads from below, spending its energy as warmth when it reaches the top. Very likely both play some part, and spacecraft have been sent to fly closer to the sun than anything ever has, dipping through the edges of the corona itself, precisely to gather the measurements that might settle it. But it is not settled yet. When you look at that pale crown during an eclipse, you are looking at something that is millions of degrees hot for reasons we still do not completely understand. And there is something rather wonderful in that, in being able to stand there and see a thing so plainly, and still be able to say, honestly, that we do not yet know everything about why it is the way it is. It would be easy to think of a total eclipse as only a spectacle, a beautiful few minutes to be watched and wondered at, and no more. But for a long stretch of history, eclipses were also among the finest tools that science had, one of the only ways we could learn certain things about the sun and about the universe that we could learn in no other way. Because an eclipse briefly hides the blinding face of the sun and lets us study the faint things around it, it has been, more than once, the setting for a genuine discovery. I would like to tell you about two of them, gently, because they are both rather beautiful and both entirely true. The first is the story of how we found a whole new part of the world, an ingredient of nature that no one had ever known existed, hidden in the light of the sun during an eclipse. To understand it, you need one simple and rather magical fact about light. When you take the light from something glowing hot and spread it out into its rainbow of colors, the way a raindrop or a piece of cut glass spreads sunlight into a little rainbow, you do not always get a smooth, unbroken band of color. Very often, that spread out light is crossed by fine, bright lines or dark lines at particular colors in particular places. And here is the wonderful part. Each kind of substance in nature, each different material, leaves its own exact pattern of these lines, always in the same places, like a signature or a set of fingerprints. So by spreading out the light of a glowing thing and reading the lines in it, you can tell what that thing is made of, even from very far away, even from across all of space. It is how we know what the distant stars are made of, without ever going to touch them. More than a century and a half ago, astronomers turned this trick on the sun during a total eclipse, spreading out the light that came from the glowing edges of it, the bright rim of gas that shows around the covered disk. And in that spread out light, they found a bright line in a particular shade of yellow that did not match the signature of any material then known on the Earth. Every line should have belonged to some familiar substance. This one belonged to none of them. The careful conclusion, bold but sound, was that the sun must contain some ingredient that had never yet been found here at home. Something new. They named this new thing after the Greek word for the sun itself, a lovely choice, for it had been discovered in sunlight before it was ever found on the ground. And only decades later was that very same substance that's finally found here on the Earth as well, confirming the whole story. It turned out to be one of the most common ingredients in the entire universe, a light and airy gas, the very same one we now use to fill floating balloons. It was first known to us, though, only as a strange yellow line in the light of an eclipsed sun. An entire piece of nature, found first not on our own world, but in the brief darkness of an eclipse. The second story is grander still, and it reaches to the very shape of space and time. A little over 100 years ago, a new picture of gravity had been put forward, a startling idea that gravity was not simply a pull between heavy things, but was something that happened to space itself, that a heavy object like the sun actually bends and curves the space around it, and that anything passing nearby, even a beam of light, would have its path gently bent by that curving. This was a strange and difficult idea, and it needed testing, and it made one prediction that could be checked, if only the right chance came along. If the sun truly bent the space around it, then the light of a distant star, passing close by the sun on its way to us, should have its path bent a little as it went by, so that the star would appear shifted, just slightly, from its true position, nudged aside by the sun's presence. But there was a problem. To see a star apparently right next to the sun, you would have to look right beside the blazing sun, and the sun's glare would drown any star near it out completely. On any ordinary day, the thing simply could not be seen. And here is where the eclipse comes in. For a total eclipse is the one time when the sun's glare is switched off, and stars can be seen in the sky right beside it. So during a total eclipse, a little over 100 years ago, astronomers traveled to the path of the shadow, and in those few dark minutes, they carefully photographed the stars that appeared close around the covered sun, and measured exactly where each one seemed to sit. Then they compared those positions with where the same stars sat when the sun was nowhere near them, and they found that the stars near the sun had indeed been shifted, nudged outward from their usual places, by just about the amount the new idea of gravity had predicted. It was a triumph. The bending of starlight by the sun, seen only because the eclipse had hidden the glare, confirmed that daring new picture of gravity and of curved space, and made its author famous around the world, almost overnight. And it was the shadow of the moon, and only the shadow of the moon, that had made the test possible. Twice over then, and in these two very different ways, the eclipse has been not just a wonder to look at, but a window through which we glimpsed something true about the universe that we could not otherwise have reached. Now, I want to speak with you plainly and calmly for a little while about how to watch such a thing safely, because it matters, and because it is easy to get right once you understand it. I will not frighten you, and there is no need for fear. There is only one simple rule to carry, and if you carry it, you can enjoy the whole of an eclipse in complete safety. The rule is about the difference between the bright part of the sun and the hidden part, and it comes down to this. You must never look at the bright face of the sun without proper protection. But during the few minutes when that bright face is completely hidden, and only then, it is perfectly safe to look with your own eyes. Let me take that carefully, in both its halves. Through all the long partial phases of an eclipse, before totality and after it, while any part of the bright surface of the sun is still showing, even the thinnest sliver, you must not look at the sun with your unprotected eyes. This is true whether an eclipse is happening or not, of course. But people forget it during an eclipse because the sun is dimmed, and it feels as though it might be all right. It is not all right. Even a small remaining sliver of the sun's true surface is fierce enough to injure the delicate back of your eye. And the cruel thing about it is that it does not hurt while it happens. The part of the eye that would be harmed has no feeling of pain, so you would not feel any warning, and the damage can be quiet and lasting. So please, through all the partial phases, protect your eyes. Ordinary sunglasses are nowhere near enough, not even several pairs stacked together. What you need are proper eclipse glasses, the specially made ones that meet the recognized safety standard for looking at the sun, which are so dark that through them you can see nothing at all except the sun itself. Or you need a proper solar filter fitted over any binoculars or telescope or camera, never the naked lens alone. And never, ever look at the sun through binoculars or a telescope that does not have such a filter, not even for an instant, for they gather the light and would do harm faster than you could blink. There is also a gentle, old-fashioned way to watch the partial phases without looking at the sun at all, and it is safe for anyone and rather charming. If you take a piece of card and make a small hole in it and hold it up in the sunlight, it will cast a little image of the sun onto the ground or onto a second card held below, and you will see the crescent shape of the covered sun projected there, small and clear and perfectly safe to look at. You can watch the whole slow bite of the eclipse this way, in the shadow, never once turning your eyes upward. It is the same trick the leaves of a tree play, scattering all those little crescents on the ground. Many people find it a lovely way to follow along, especially with children, who can make their own little pinhole and watch the sun change shape in a patch of light at their feet. And now the other half of the rule, the kinder half. During those few short minutes of totality alone, when the moon has hidden the sun's bright face completely, and only the soft pale crown of the corona is left, it is perfectly safe to lower your eclipse glasses and gaze straight up at the sky with your own unguarded eyes. Indeed, you ought to, for the corona shines far too faintly to be seen through the dark filters at all, and this is the single time in the whole event when you are meant to look freely. This is the sight that people cross oceans and continents to witness, and it is meant to be taken in with nothing at all between your eyes and that pale crown. So once the final diamond has died away, and the deep shadow has swept over you, and the corona has opened out around the black disk, lift the glasses from your face and simply look. It is safe, and it is the very heart of the whole thing. But you must be ready for the ending, for here lies the one moment that calls for care. Totality lasts only those few brief minutes, and it closes as abruptly as it opened. At the far rim of the darkness, the first small point of the sun's brilliant surface will leap back into view, the diamond ring returning now on the opposite side, the first bead of true daylight flaring out once more. And the very instant it does, the instant you catch that first returning spark of brightness, it is time to turn your gaze aside and slip your protection back on, for the blazing sun is coming back and is once again far too strong for an unshielded eye. So the way to keep it all in mind is simple and gentle. While the sun lies wholly hidden, look freely and treasure every second. The moment the diamond ring reappears, look away and let the glasses return to your eyes for the partial phases still to come. And that is all there is to it. One clear rule, softly kept, and an eclipse becomes one of the safest wonders you could ever travel to see. For almost the whole of the human story, no one knew any of what we have talked about tonight. No one knew that the moon cast a shadow, or that its path was tilted, or that the sun had a crown of thin hot gas. People only knew what they saw, which was that on some rare and unlooked-for day, without warning, the sun began to go out. Imagine what that must have been like, before any of the explaining, before anyone could tell you it would pass. The sun, the steady giver of all light and warmth, the one utterly dependable thing in the whole of the sky, begins in the middle of the day to be eaten away, and the light fails, and the air goes cold, and the birds fall silent, and darkness comes at the wrong hour. It is no wonder at all that people met such a thing with fear. The darkening sun was imagined as something being attacked or swallowed, a great creature devouring it, a dragon or a beast or a pair of jaws closing over the light, and people would make noise, shouting and beating drums and pots to frighten the creature away and make it give the sun back. And because the sun always did come back, within a few minutes, the noise seemed to work every time, and the custom held. In other places, the darkening was read as a sign, an omen of some great event, the anger of the heavens, a warning of trouble to come. I want to speak of these old beliefs with respect, because they came from real people meeting a genuinely frightening thing with the understanding they had. But I want to be clear and honest too, in the way we have tried to be all night. An eclipse is not an omen. It does not foretell events, or carry messages, or bend the course of any life. It is the shadow of the moon falling across the turning earth, following rules as steady and as harmless as the phases of the moon or the coming of the tides. The fear was real and understandable, and it was also, we now know, unfounded. What changed the fear into something calmer was one of the quiet triumphs of the human mind, and it is worth pausing on. People who watched the sky carefully, over long lifetimes and across many generations, keeping patient records of when eclipses came, began to notice something. Eclipses were not scattered at random through the years after all. They followed a rhythm. There was a long cycle, a stretch of a little over 18 years, after which the whole dance of the sun and moon and earth returned very nearly to the same arrangement, so that an eclipse much like an earlier one would come around again. This long rhythm, this roughly 18-year cycle, was noticed and tracked by careful sky watchers in the ancient world, who kept their records on clay and stone across the generations. And once you know the rhythm, something extraordinary becomes possible. You can begin to predict. You can say, before it happens, that the sun will darken on such and such a day. The thing that had been a bolt of terror from the heavens became something that a patient person, with good records and a long memory, could see coming. Those patient old records have turned out to be a quiet gift to us as well, in a way their keepers could never have foreseen. When ancient watchers wrote down the day and the place that the sun or the moon went dark, thousands of years ago, they were only marking what they saw. But an eclipse is such an exact lining up of the sun and the moon and the earth that, knowing the rules as we now do, we can work out precisely where on the earth the shadow should have fallen on any given day in the deep past. And when we compare where those old eclipses ought to have been seen with where they actually were seen, according to the ancient records, we find a small mismatch, a gap that has grown steadily over the centuries. That gap tells us something we could learn in almost no other way, that the turning of the Earth itself has been very slowly winding down, the days growing a tiny fraction longer over the ages as the tides drag gently against its spin. The careful eclipse notes of scribes who lived thousands of years ago, kept for reasons of their own, now let us measure the slowing of our whole world. It is a lovely thought that a record of one darkening sun, scratched onto clay in a language long since dead, should still have something true to tell us all this time later. There is an old story, told for a very long time, of a battle that was halted by a sudden daytime darkness. According to the tale, two armies had been fighting a long war, and in the middle of one of their battles, the day turned to twilight and the sun went out, and both sides were so struck by it that they laid down their weapons and made peace. It is said that the darkening had even been foreseen, guessed at in advance by an early thinker who had learned something of the rhythm of these events. Whether every detail of that story is exactly true, historians still gently argue, and I will not pretend to you that we can be certain of it. But true or not, in its particulars, it captures something real about the turning point we are describing. The moment when eclipses began to pass out of the hands of dread and into the hands of understanding. To be able to say calmly and in advance that the sun will go dark on a certain day and then return unharmed is to take one of the most frightening sights in nature and make of it something you can look forward to. And that, in the end, is what happened. Over the long centuries, the swallowed sun and the angry omens slowly gave way to the predicted event, the marked day, the thing people now travel toward on purpose, cameras in hand to stand in the shadow and feel the old awe with none of the old fear. The wonder is still there. It never left. Only the terror has gone, replaced by understanding, which is a fair trade and a very human achievement. Perhaps, listening to all of this, you have begun to feel a small, quiet wish stirring somewhere. The wish to see such a thing for yourself one day. To stand in the shadow just once and feel the day go dark and the crown of light appear. If so, I would like to tell you, gently and practically, how such a thing might be found, because it is more possible than you might imagine. You do not have to hope to be lucky enough that an eclipse comes to you. You can, if you ever wish to, go to meet one. Total eclipses of the sun are rare for any one place, as we said, but across the whole of the Earth, they are not so very rare at all. Somewhere on the turning globe, a total eclipse falls, on average, about once every year or two. The trouble is only that its narrow ribbon of shadow so often lands on empty ocean, or on some far and thinly peopled corner of the world, which is why seeing one usually means a journey. But the paths are known, worked out far in advance with wonderful precision, for we understand the dance of the sun and moon so well now that we can say exactly where the shadow will fall, and at what minute, many years before it happens. The dread of our ancestors has become a printed schedule, a set of maps you can look at in advance and plan a trip around. There is something rather beautiful in that, in being able to know calmly and for certain where a piece of wonder is going to touch the earth. And there is one coming before very long, which I will tell you about softly, in case you should ever wish to go. On the 12th of August, in the year 2026, the shadow of the moon will sweep across the far north of the world, and down into the edge of Europe. It will pass over parts of the frozen reaches of the far north, crossing eastern Greenland and then the western side of Iceland, that island of fire and ice out in the Northern Sea. From there, the shadow will race down across the open ocean, and in the early evening, with the sun sitting low and golden over the horizon, it will reach the northern part of Spain and brush the very edge of the land beside it before the day ends. For the people standing along that path, for a couple of quiet minutes, the low evening sun will vanish and the corona will bloom in a twilight sky. It will be the first time in more than a quarter of a century that the deep shadow has fallen on the mainland of Europe at all, and the first time in well over 100 years for the mainland of Spain. So it is a genuinely uncommon homecoming of the shadow to those shores. And it will not be the last. These things come in their long, patient rhythm, and there are more to follow in the years just after. The very next summer, another total eclipse will draw its path across North Africa and the lands around the southern edge of the Mediterranean, and that one will linger far longer in darkness, holding some places in shadow for many minutes rather than a couple, one of the longer totalities that this whole age will offer. And there will be others after that, each in its own year, each tracing its own narrow band across some part of the world, on and on into the future, as steady and as certain as anything in nature can be. If you ever find that the wish has taken hold of you, there will be a shadow to go and meet. I will not tell you that you must go. These recordings are for resting, not for making plans or feeling that there is somewhere you ought to be. But I will say this, quietly, as something worth knowing. Almost everyone who has ever stood in the path of a total eclipse says afterward that it was unlike anything they expected, that no description and no picture had prepared them, and that they are quietly glad, for the rest of their lives, that they went. It asks only a little of you, a journey to the right place on the right day, and a few clear minutes of weather, and it gives back something that seems to stay with people, a memory of standing under a black sun ringed with pale fire, with the sunset glowing all around and the stars come out at noon, and feeling, for a few short minutes, very small and very lucky, beneath a sky doing something it hardly ever does. If the chance ever comes your way, and it can be arranged, it may be one of the loveliest things you ever choose to see. But that is for waking life, for daylight, and plans and journeys, and none of it is for now. For now, there is only here, and the quiet dark of your own room, and the soft weight of your own tired body settling deeper into the bed. So let us bring the eclipse gently to its close, the way every eclipse ends, and let the light come home. Picture it one last time, slowly. The corona has hung there in the twilight for its few short minutes, pale and streaming around the black disk of the moon. The stars have shone at midday, and the sunset has glowed all the way around the rim of the world. And now, at the far edge of the darkness, the shadow begins to slide onward, racing away across the land as fast as it came. On one side of the covered sun, a single point of light springs suddenly back to life, the first returning bead of true sunlight, and it swells in an instant into the diamond ring once more, a jewel of brightness blazing at the edge of the dark moon. The pale crown fades from view as the glare returns. The deep twilight lifts. The band of sunset around the horizon melts back into ordinary sky, and the light comes flooding back across the land, that strange silvery daylight brightening and warming and turning gold again, The shadows softening, the chill lifting, the birds beginning once more to sing, a little confused, as though a very short night had come and gone. Within a few minutes, it is simply a bright afternoon again, as if nothing at all had happened, only a slowly shrinking dark bite in the edge of the sun to show that anything ever did, and soon even that is gone. The moon slides quietly off the face of the sun and drifts away along its patient path, invisible once more in the glare of the day, and the world goes back to the way it always is, warm and ordinary and unremarkable. But everyone who stood in the shadow carries it away with them, that handful of minutes, folded up somewhere inside where it will stay for good. The eclipse is over, and the sun is whole again, and the day goes on. And so, in the same gentle way, we let all of it drift now out of your mind. The shadow and the crown, the beads of light and the diamond ring, the tilted path of the moon and the crown of the sun that is hotter than anyone can fully explain. You do not need to hold on to any of it. It will keep. The sun will go on pouring out its light whether or not you think of it, and the moon will go on tracing its slow tilted path around us, and every so often, somewhere on the turning earth, the two will line up, and the shadow will fall, and a small pool of night will race across the daylit world, whether or not anyone is there to stand in it. It has been happening since long before there was anyone to watch, and it will go on long after, steady and harmless and quietly wonderful, out there in the great slow clockwork of the sky. So let your thoughts grow soft and dim now, like the last light fading before the shadow falls. Let the pillow take the whole weight of your head. Let your breathing slow and lengthen, easing gently out into the dark. There is nothing you need to do, and nowhere you need to be, and nothing left to hold in your mind. The sun has set in its own way, and will rise again in its own way, and none of that is yours to tend tonight. All of it will carry on without you, patient and sure, while you let go and rest. Sleep now, warm and safe and still. The shadow has passed, the light has come home, and so gently have you. Rest well and sleep soundly through the night.